Hey guys, so today's focus for this lesson is going to be the 7th grade Geometry Standard 4, and we're going to be talking about how can I determine the circumference and area of a circle. So before we start calculating the circumference of a circle, we need to talk about a few key vocabulary words. The first thing that you need to know about a circle is the radius. So the radius of a circle is the distance from the center of a circle to the outer edge of a circle. So it's going to look like this. It's going to be a straight line from the center to the outer edge of the circle. It can be drawn many different ways. Typically you'll only see one radius drawn, but it could be kind of going down like this, as long as it's from the center to the outer edge. It could be going up like this. But anytime you see a radius, it's going to be from the center to the outer edge. So any way you draw it, it's going to be the same length. So you really only need to see one radius of a circle to know that length. The next vocabulary word that is important to know is diameter. So the diameter is a straight line through the center of a circle. Its endpoints are on the outer edge of a circle. So it looks like this. And if you'll notice that if we have the radius from earlier, just a second ago, it looked like this. And if we took another radius and put it in the opposite direction, it would go across like this, and it would make a diameter. So if you have two radiuses going in opposite directions, they form a diameter. So there is this relationship between, for every two radiuses, that's equal to one diameter. So R is radius, D is diameter. And that'll be kind of important when we talk about formulas for circumference of a circle, because you'll see one formula written using R for radius and another formula written with a D for diameter. So two radiuses make the diameter. Alright, and then the last vocabulary word we're going to talk about really quickly is circumference, because that's what we're going to be trying to find first, is the circumference of a circle, and that is the distance around the outside of a circle. So for other two-dimensional polygons, we would call that perimeter, but since circles have a curved edge, we can't really just add up all the sides because it's really just one long circular edge. So to calculate that, we are going to have to get a little bit more creative and use a formula. So the green line represents the circumference. That's just the distance around the outside of the circle. Alright, so let's take a look at this cool formula. So C equals 2 pi R. So there's a few things, or there's really just one big major thing that a lot of you are like, what in the world is this? And that's this nifty little symbol we call pi. And look right here. So that is pi. So that's going to be something that's new to you now. So let's hop over to a cool website that is all about pi. And it's like there's even a day celebrated called Pi Day. And that's, I think it's March 14th because it's 3.14, which is what we usually use to represent pi. So let's just read just a second. So pi is one of the most well-known mathematical constants. It is the ratio of a circle's circumference to its diameter. For any circle, the distance around the edge is a little more than 3 times the distance across. So most of the time when you type pi into a calculator and press enter, you're going to see 3.141592654, and that's not because this value is exact, but because your calculator display is often limited to about 10 digits. Some calculators are smaller, so you may not even see that many decimal places. But pi is actually this cool thing called an irrational number, which is just a number that is a decimal with no end and no repeating pattern. Okay, but anytime we're using pi this year, we're most of the time going to use the approximated form of it, 3.14, and that's where Pi Day comes from, the 3rd month, the 14th day of the 3rd month. So it's a little fun fact there. Or you might also see a fraction used, 22/7. Most likely we're going to be using 3.14 as our approximation of pi this year. In 8th grade, your calculator has a nifty little pi button, so it's a lot easier to actually use the pi button in 8th grade. This little animation here is really nifty because it shows you the diameter. Well, there it goes. So the diameter is the width of the circle, and you see they've wrapped the diameter 1, 2, and 3 times, and this little blue is the 0.14159 and so on. So that's just kind of this little extra piece of the diameter that we need. And here's like a really interesting question. And it's something I just really don't know the answer to, but it's a fun thought. If pi is the number of diameter lengths that fits around a circle, how can it have no end? So that's just kind of a little moment for you. So now let's kind of hop skip. Now that we know a little bit more about pi, we can actually start to use pi with our new little formula to find circumference. Alright, so one formula that you will see for circumference is C equals 2 pi r, where C is representing, you guessed it, circumference. I'm going to draw a nice little arrow to circumference because that's what C stands for. 2 is just 2 times pi, which we're most of the time going to approximate that to be about, I'm going to use my little approximation symbol, 3.14. And R stands for your new vocabulary word of radius. Alright, and then if you'll remember back to when we were talking about radius and diameter, so remember that for every 2 radiuses, that is equal to 1 diameter. So we could actually take this formula here, since we have 2r there, and we could write it also as circumference equals pi times your diameter. So both of these formulas can be used to find circumference. You can use either one. You can use both of them depending on the problem. So either one is good and fine there. So the second one is just circumference equals pi times your diameter. Alright, so let's take a look at a few examples. So first we're going to find the circumference of each circle. And I'm just going to start off by writing down my formula just so I can plug in my values. So C equals 2 pi r. So r is my radius. So if I look at my problem here, I'm given my radius because that's going from the center of the circle to the outer edge. They're not going to try to trick you here, so don't try to get too technical with it. If they give you a line that looks like it's going about halfway or to the center of the circle to the outer edge, it's your radius. They're not going to try to be like, oh, gotcha, that's not all the way to the center. So just kind of, if it shows you about halfway through the circle to the edge, it is your radius. So here we're looking for circumference, so C is our unknown, so we're going to leave it as C. I'm just going to bring down my 2 because it's just a constant. For pi, I'm going to approximate that as 3.14. And then my radius from my problem was 8. And so now you're going to take out your handy dandy calculator and you're going to type this in. You're going to type in 2 times 3 14/100 times 8. And you should get 50 24/100. And now since my radius was in feet, my answer is in feet also. So my final answer would be 50 24/100 feet. Alright, number 2. This one is a little bit different. I'm going to stick with my formula from earlier. C equals 2 pi r. But in this problem, I'm not given the radius, I'm given the diameter. So 12 goes all the way from one outer edge through the center to the other outer edge. So by definition, that is our diameter. I'm going to label that diameter. So now to find my radius, I have to cut my diameter in half or divide it by 2. So 12 divided by 2 is 6. So my radius would be 6 inches. And that's my radius. Alright, so now I can plug this into my formula and calculate the circumference. So my circumference is C equals 2 times pi, which I'm going to again approximate as 3.14, and my radius we found was 6 inches. So now again I'm going to pull out my handy dandy calculator and calculate away. 2 times 3.14, ooh, I mistyped, times 6. Always be careful when you're typing into your calculator. I like to type things in twice because if I mistype the first time, especially on these 7th grade calculators, you can't see exactly what you typed in on the screen. So if it looks kind of outrageous, type it in again and see if you get the same answer, because sometimes you might mispress a button. So you should have gotten C equals 37 68/100ths, and my radius and diameter were in inches, so my answer will also be inches. So that's 37 68/100ths inches. Alright, in my third example, I think you've probably got it by now, but I'm going to go ahead and show you an example with another decimal number. With our calculators in our hand, it's not difficult to do because you're just going to type it in carefully. So again, you're going to use your formula, C equals 2 pi r, and you really do need to try to memorize this formula because you will be using this a lot in 8th grade whenever we're talking about geometry and volume of cylinders and things like that. So you will see this again. If you've already got this formula, not squared, where did that come from? If you've already got this formula in your head, then it's just going to help you for a little bit more in 8th grade. Alright, so again, I'm looking for circumference, so that's my unknown, so I'm going to leave that as my variable. 2 is a constant, so just bring it down. Pi we're going to approximate to be 3.14. And then my radius here they gave me was 4.5. Okay, because again, it's going from the center of the circle to the outer edge. That was kind of a bad drawing there. That should be kind of finished out. Again, they're not trying to trick you there. Alright, so type this into your calculator. 2 times 3.14 times 4.5. And you should get 28 26/100ths. And again, my radius was given in inches, so my circumference is in inches. So that will be my final answer. Alright, so that is how you calculate the circumference of a circle. Next, we're going to look at how to calculate the area of a circle. Now, the area of the circle is the number of square units that are inside a circle. Basically, in layman's terms, that's how much space is inside of my circle. Usually, like, how much space is my circle taking up? That should sound familiar from, like, finding the area of a square or a rectangle and all those other shapes. So it's how much space does the inside of my circle have or take up? Okay, so it's all of that. And so they, again, give us a nice little formula for this. This is another formula that you're going to want to kind of have stuck in your brain for 8th grade. Area equals pi r squared. And now we haven't seen exponents in a little while, especially since we've been out of school. So let me do a quick refresher on what squared means. So squared is, so if I have the number 3 and it's squared, so it's got the exponent of 2 above it, that just simply means 3 times 3. And if I have like a 4 squared, so it's got my exponent to the top right, that's just 4 times 4. If I have 12 squared, that just means 12 times 12. So hopefully by now you've seen the pattern. If it's squared, it's just that number times itself. Alright, so let's kind of look at this formula here. I bet most of you could probably guess what R stands for. That stands for radius, and remember your radius goes from the center of your circle to the outer edge. Pi, again, is going to be approximated for 3.14. And then A just stands for area. So again, let's look at a few examples here. So number 1, I'm just going to start by writing my formula. We're going to find the area of each circle. So area equals pi r squared. And I'm going to plug in what I know. So for number 1, they gave me the radius, because it's from the center of the circle to the outer edge. So I'm looking for area. So area equals, we're going to substitute in 3.14 for pi. I'll draw you a little arrow. And then my radius squared is going to be, I don't know, 8 squared. So area equals 3.14, and so I'm just going to type it in my calculator as 3.14 times 8 times 8. And now let me just type it in just like I see it. 3.14 times 8 times 8, and that gives me 296 hundredths. And that my radius was in feet, so that is going to be feet squared, because remember, area is a two-dimensional measurement. Just like when we talked about squares previously, you had a length times width, so you were multiplying two dimensions. Well, a circle doesn't have a length and a width, but using this formula we can still calculate the amount of space that it's taken up. So it is still a two-dimensional measurement, so you're going to have your units squared. So it still will be feet squared. Alright, so number 2, we're going to start by just writing down our formula. I'm going to change colors to kind of help you out a little bit. So area equals pi r squared. Here again, they did not give me my radius, but remember the radius is half of your diameter, so I'm just going to take half of 12. So I'm going to divide 12 by 2, and that gives me 6 inches. Alright, so now pi, I'm going to approximate that to be 3.14 times my radius, which is 6 squared. Alright, so type that into your calculator. You're going to just say 3.14 times 6 times 6. And I get 113 4/100. And again, my radius and diameter was given to me in inches, so my answer is going to be inches squared, because that is a two-dimensional measurement. Alright, and number 3, again, you've probably got it by now, but I'm going to go over one more. So area is pi r squared. Here they've given us our radius, so let's just plug it in. So 3.14 for pi times my radius, 4.5 squared. So I'm going to type that in my calculator, and I'm going to say 3.14 times 4.5 times 4.5. And that gives me 63 and 585 thousandths. My radius is given to me in inches, so my answer will be in inches squared. And that is how you calculate the area of a circle. Alright, so if you feel like you're still a little unsure, this gives you a list of a couple of videos on YouTube. It's Math Antics. Math Antics is a really good place to find a little bit more animated videos, has a lot more cool animation, you can tell this person has put in a ton of time on these videos and made them really something cool and kind of interesting. So if you want a little bit more information about it or want to see some more examples and see it broke down a little bit more, Math Antics Circles, What is Pi is a good video, and also Math Antics Circles, Circumference and Area. These are two wonderful videos. Honestly, I watched them to kind of see how I might lay out my videos, so you might hear us talk about some of the same things. And then the website that I used that was about pi was www.piday.org. So you can go back on there and kind of look up some more cool information about pi if you would like. But that's all for now, folks. See you in the next video.